Nmap is the predominant port scanner for network security professionals. It was originally created by Fedora and released in this article for FRAC Volume 7, Issue 15 back in 1997. Now Fedora and a host of open source developers contribute to the project. Nmap's main webpage can be found at http://www.insecure.org/nmap. Nmap supports many platforms. For this tutorial, I will be using the Auto-to-Boot CD, which comes with Nmap 3.75. Nova Port Scanner seems to offer the wide range of options that Nmap provides. This tutorial will cover the basics of Nmap usage, along with a few of its more advanced options. Ports are numbers that TCP/IP uses to map packets to services. For example, some of the common ports are presented on your screen right now. You can think of the IP address as an apartment complex and each port as a mailbox. Each resident or service needs their own mailbox to receive messages. TCP also uses flags to communicate. The send flag or synchronize is used for establishing a connection. The ACK or acknowledgement flag is used for acknowledging a message. The reset flag is used to indicate there was some kind of error. And the finish flag is used to tear down a connection. The other flags we won't worry about for the time being. Nmap has the ability to do all sorts of scans, but the two most common are SYN and TCP Connect scans. The top animation illustrates a SYN scan, which is the default scan type if you are logged in as root. Nmap will send a SYN packet to a certain port on the target host. If that port is open, the target will send back a SYN acknowledge packet. Now that Nmap knows that the port is open, it sends a reset packet to break the connection. SYN scans have the advantage of being more stealthy than a full connect scan, but a good IDS will still detect them. The middle animation illustrates a full TCP Connect scan, which is the only scan type you can do without root privileges. Full TCP Connect scans do a complete three-way handshake. Nmap will send a SYN packet to a certain port on the target host. If that port is open, the target will send back a SYN acknowledge packet. Now that Nmap knows the port is open, it completes the connection with an ACK packet, then finishes communications. The bottom animation shows the most common results of either scan type when scanning a port that's closed. Nmap will send a SYN packet to a certain port on the target host. If that port is closed, the target will send back a reset packet to indicate a problem exists since nothing is listening on that port. It's also possible that the target host will not return any information at all. If Nmap knows that the host is up, but it did not return anything for a certain port, Nmap will label that port as being filtered. Filter could mean the host is behind some sort of firewall obstruction, but if the firewall is configured a certain way, getting back a reset packet is also possible. Now let's boot up the Auditor CD and start using Nmap. First I'll do a simple scan of a known host. Notice that Nmap found some open ports, tells us which services commonly run on those ports, the MAC address of the target machine, and the vendor that that MAC address belongs to. Since I'm logged in as root, Nmap did a SYN scan by default, but I could explicitly do a SYN scan with the following command, or a TCP full connect with this command. The default port range that Nmap scans is 1 through 1024 and every higher port in the Nmap services file. I'll go into how to change the port range later. When scanning hosts, there are a lot of options you may want to use to find more information about the targets. Look at Nmap's man page to see them all. Here are a few of the most commonly used options. -H gives you the Nmap help. Not as comprehensive as the man page, but still good for a quick fix. -S capital S gives you the TCP scan option, which we've already covered. The same goes for -S capital T, which gives you the TCP full connect option. -S uppercase U gives you the option of scanning UDP ports as well, though keep in mind that return results on UDP scans are not as reliable as TCP scans, as far as what port is actually open or not. -V gives you verbose output, telling you more information about the current scan. -V gives you even more verbose output. -O will try to do an operating system detection, also known as TCP/IP fingerprinting. Different operating systems have different ways of responding to certain kinds of messages. And by how to respond to this, Nmap can try to guess as to what operating system is running on that machine. -V will try to do a service version detection. For instance, if you want to find out what version of SendMail they're running on port 25, this would be the option to go with. -P0 tells Nmap not to try to ping the host before scanning it. By default, Nmap sends an ICMP echo request and a TCP ACK packet to port 80 on the target machine, and if it receives back a response, it knows that machine is up. However, since some target hosts will block this sort of traffic, you may want to tell Nmap to go ahead and scan anyway, even if it can't ping it. -A stands for aggressive, advanced, or additional. Fedora hasn't exactly made up its mind what it is yet. In the current version of Nmap, using the -A is the same as using both the -O and -S_V at the same time, but extra functionality may be added into later versions of Nmap. The -T allows you to set pre-canned timing options. This basically controls how fast Nmap scans the target hosts. The faster you scan, the quicker it's going to complete, but also the less stealthy it would be. Also less reliable. Doing slower network scans will cause less congestion on the network and also be more stealthy. I would recommend only using the insane setting if you're on the same local area network as the target host. -P gives you the option to choose which ports you wish to scan. For instance, I could say ports 1 through 80 by using 1-80. Or I can say ports 80 and 25 by going 80, 25. -F tells Nmap to do what's known as a fast scan. A fast scan looks only at ports listed in the nmap-services file. The -N parameter tells Nmap not to do a reverse DNS lookup. This can also increase the speed of scans. In this Nmap command, I'm using the -VV option and the -P0 option to tell Nmap to give me very verbose output and to scan the machine without pinging it. Here I'm using the -O to tell Nmap to do an OS detection on the target host. This is also known as TCP/IP fingerprinting. Depending upon how the host responds to certain types of packets, Nmap can take an educated guess as to what operating system that machine is running. This command tells Nmap to see if port 5901 is open and to do an OS and version detection. As we can see, this host is running a VNC server, protocol version 3.3. Be careful when using the version detection option. The data it sends to probe the host can cause the target service to have problems. I once scanned the JetDirect box with version detection and caused it to print off every fingerprinting test, wasting about half a ream of paper. In this command, we use Nmap to do a UDP scan. We use the -A option to do an OS and version fingerprint, and we set the timing options to insane, so that we get our results back faster. Now we do a UDP and send scan so we can see both open UDP ports and TCP ports. We tell Nmap we wish to probe only UDP ports 130 through 140 and TCP ports 1 through 1024. There are a few ways we can specify more than one target for Nmap to scan. Here are a few: wildcard notation, range notation, and mask notation. All of the above notations would scan the same Class B network. This command tells Nmap to do a fast scan with OS detection on hosts 192.168.1.102 through 105. As you can see, this scan returned results for more than one host. Here we tell Nmap we wish to scan a complete Class C network. I hope that you've enjoyed this tutorial. For further research, you might want to look at the Nmap documentation at insecure.org and the Horse 13's Nmap tutorials on Anti-Online. Later I may release another Nmap tutorial showing some of the more advanced features, like FTP bounce, spoofing, decoys, logging, and idle scan. Email irongeek@irongeek.com if you would like for me to do a more advanced tutorial.